Here's a weird one. You have your 10, 5, 25. There's a little way we have to worry about. So first thing you're going to do, you're given the acute angle. They're given the acute angle and the side opposite it. That means right off the bat you're going to be looking at law of sines because you know the angle and the side opposite. Which means I'm going to check my rules. Remember, your rules is take the side not opposite, sine of the angle, and you're going to check in relationship to the other side. Is it going to be smaller or is it going to be greater? If it was greater, there was no triangle. If it's smaller, then we have the possibility of it being two triangles because then it might be smaller than that other side as well. So in the calculator, what is 25 times the sine of 10?
It's less than
4 point something, right?
Yeah.
4.3.
4.34.
Okay. Which is smaller than 5, which is also smaller than 25. So that means that we're going to have to solve for two triangles. So what we're going to do here is solve for angle C first, because we know the side opposite it, we don't know the angle. We're going to use the law of sines. We're going to use sine of 10 is to 5, bless you, as the sine of C is to 25. Cross multiply and solve. You get 60.25, yep. Now, since I know that I'm going to have two possible triangles, I have found one triangle to work with. The other angle, or excuse me, one angle to work with. The other angle is going to be 180 minus the 60 1/4, which is 119.75. So what's happening now is that you have two possible triangles. One of the triangles looks like this. And sometimes it's nice to draw it out if you want.
Wait, wouldn't it be 180 minus 70 points?
No, I'm just doing with C. I haven't gotten to the other part yet. Okay? Right now, one of my triangles, gentlemen, I don't want to talk over you. The original triangle had a 10 here, and it was 5 at B, correct?
Yes.
This was a 25. So now we have a 60 1/4 there, which means I can find A relatively easily just by subtracting out. In the other triangle, we still have 5, a 10. This angle now is 119.75. And I can still find A for the other one. What I'm doing here is, once I know that I'm going to have a two triangle setup, I just redraw two diagrams and resolve for A just by subtracting out from 180 degrees. Does that make sense? Yeah, Lena.
Does 5C change at all?
No, it does not. It does not, because what's going to happen is that it's still going to have that same value of 25, just because the other angle is changed, that length stays the same.
Would A be different?
Yep.
Solve for A twice?
Yep. So what happens now in this side here, I take 180 and I subtract out the 70 1/4, and I get, what is that, 109.75. And then I would use law of sines to find out the side A. Over here, when I subtract out from 180, I have 50 1/4. So what happens is if you have a 10-degree angle up top, the two other angles that can be formed with these side lengths are going to be 119 or 50 and change. Here, if it's 10 with this side length, it could be a 60-degree angle and a 109. It just, when the law of sines gives you, since this was acute, that has the possibility of occurring. To find little a on both of these, you're just using law of sine again to get that. When you do it, you get 27.1, and this was 22.14. Do you want me to walk through the law of sine? That's usually pretty straightforward. Yes, sir.
Do you have any other examples of these?
Of the ambiguous one? Not off the top of my head. Okay. Yeah. Very straightforward. Okay. Very, very straightforward. Yes, sir.
Will we have any double triangles?
Probably. Yes, sir.
So whenever probably should check.
Always check your, that B sign A versus little a, if it's acute.
I thought that's only for angle side.
When you're given an acute angle, if you're using law of sines, if you have to use law of sines, you look at this. And then again, if it winds up being smaller than the B, that's when you have two triangles. Got it.
Are you sure that's today?
That's when you're working with acute angle, yeah.
And then is it?
Because it was obtuse angle, as long as the largest angle or the largest side is crossing the largest angle. Yes.
Otherwise,
Sean, did you have your hand up?
I don't know that. Is it any time we're dealing with law of signs? I thought in the book it said we only do it if we have an angle side or side angle. Only.
I think it's the side side. Yeah, I think it was the side side. So you have to take a look, because sometimes even law of cosines could push you into that for that secondary problem.
Wait, how do you?
Do we have to memorize them?
What?
The rules?
It might not. That's really the only one you really have to memorize. The other ones are pretty self-explanatory.
Like obtuse and stuff.
Yeah, that one's okay. Yes, ma'am. Yeah, sure. Not a problem. Number 28. What angle did you start with? Largest. Start with the largest angle because then it alleviates the problem of having that ambiguous case. Because if you start with the smallest angle, you're going to wind up with, or smallest side, you'll probably wind up with an acute angle, which means you'd have to test it, because then there would be another triangle next to be formed. So if you remember, go with the biggest side, you'll be all right.
Is that any time we're using law of cosines?
Yes, always go for the if you have the three sides, find the largest angle first. Works much cleaner. So here I'm going to find, which angle am I going to find? Yeah, the one across with B. So I just set it up as 26 squared is 5 squared plus 25 squared minus 2 times 5 is 25 cosine of B.
Can you run over a side angle side one?
I will.
All right.
So again, in this case here, it's just a matter of subtracting out 26 squared minus 5 squared minus 25 squared. Hit enter. Divide that by, are you putting parentheses when you divide? Are you putting the -2 in there? Are you sure?
Are you working yet?
Second, are you hitting cosine? Are you hitting tangent by mistake? Bless you. Okay. So once I find one of the angles in a cosine problem, just go right to law of sines then. What are you typing? Okay.
Wait, so is it B is 95?
And change. 95.97 on your FM dot.
What's it?
Radio.
Oh, okay. Oh, we're still talking about that.
Oh, you told your people, Brian.
Huh?
You tell it?
He's just automatically that go right. What else? Oh, you wanted to side angle side.
Yeah.
Okay. Which one was that?
I don't think there was any, because there was one, but it was the 90-degree one, and I didn't recognize it.
The other side angle side is was the
Like, I just don't know how to set it up. Like, what do you do when you have B squared at the beginning?
when you have a side angle side, it's you're gonna find that other side first. That's the one that goes straight forward. That was I don't know if I had a problem like that.
There was, but I didn't get it down as a moment, so like I just got the answer from the notes.
Oh, like 17?
Yeah,
Okay.
something like that.
If I look at one like that, this one isn't in here, guys, but there was a question came up about how, what do you do when you set up a side angle side? When I look at this one here, the only thing I can find right now is little c. Do you agree?
Yeah.
So when I do that, I can say c squared is 15 squared plus 20 squared minus 2 times 15 times 20 times the cosine of 40. And I can type that right into my calculator. So 15 squared squared plus 20 squared minus 2 times 15 times 20 cosine 40. You hit enter and take the square root of that answer, and there's side C.
So you just type everything right in?
That's right.
Oh, right.
Finding that missing side, the side opposite, the angle of law of cosines, is the easiest form.
And then you can just do sines.
Yeah, it's that quick. All right, it's nice when they're like that. It makes life a lot easier. Or it'd be easier if you knew it was the right triangle. Did you get it? What else we got? All right, hold on to this one. Let's talk about the last little bit of this section. Tomorrow's quiz.
May or may not.
This does not help me.
Wait, question.
So here's what we do. Yes, sir.
Would it be like solved using Heron's formula, or would it say find the area using Jewish formula?
If you don't know if you don't know what all three sides are, you can't use the other methods.
You can just like move them around and like find all the other numbers and then just do that.
Okay, all right. Yes. Chill, pickle. Please. So 3 plus 4 plus 5 over 2. What's 3 plus 4 plus 5?
A number.
All right. That is that value of S, the semi-perimeter or the half perimeter of the triangle. It's halfway around it. In order to find the area, all you have to do then is take the square root of 6 times 6 minus 5, 6 minus 4, 6 minus 3, and there's your area. Again, in the calculator, you can type that directly in. 6, parentheses, 6 minus 5, 6 minus 4, 6 minus 3. Your area is 6.
Because it's 6, 12, 36.
It's a dumb, it was kind of, Bomber happened to give me a 3, 4, 5, which we all know is a right triangle. So the area of a right triangle is 1/2 base times height. So 1/2 of 3 times 4 is 6. Look at that. It works. Again, this is one of those things where it'll state, use Heron's formula. You add up the sides, cut them in half. Square root of S, and then you subtract them off each time. What's that? I'll show you. Okay. Let's try another one like that. Again, if I have side lengths of 22, 40, and 50, first thing I want to do is find the value of S. I just add them all up. And I cut it in half. 90 and 22 is what? 1/12. Half of that is 56. So the value of S is 56. So square root. 56. 56 minus 22. 56 minus 40. 56 minus 50. And you type it in exactly the way you see it, and lo and behold, it'll spit out the correct answer if you put your parentheses in correctly.
So it's square root of S times S minus all of the sides.
Yep.
Individually.
Yep. Okay. What did you guys get?
427.5.
427 point what?
5-3.
Something squared. We're talking about area that has units. Okay. Again, it's very, very straightforward. When you're dealing with the other one with the signs, that's when you had the you had side angle side. Something like that. You would take 1/2 side times the sine of your angle.
what is that?
We need to know that.
Yeah, that was very easy.
That was BC sine
Yep. What's that?
1/2.
Yes, it is. So side angle side, you'll use this one. All three sides, you use the S one because it's silly. I'm sorry.
S just equals A plus B plus C over 2.
Yep.
Alright, so I think I
So it's the average.
No.
Oh, just kidding.
Yes. All right. Let's do a couple more examples. Let's solve out. Let's do 5 and 7. Solve the triangles. We start going around. We have the 20, 120, and 100. Obviously, what I want to start out with is to find side B. Use the cosine law of cosines. So b squared, 100 squared, plus 120 squared, minus 2, 100, 120, cosine of 20. When I type that in,
Do it with someone who has
100 squared plus 120 squared minus 2 times 100 times 120 cosine 20. 120.86.
120.86. I got 109.9.
42. I got 42.
You got 42.98. Also, please scroll up.
Actually, just agree with CB. So you have
42.9.
Wait, did you guys do something? Not yet. I'm pretty sure I lost it.
I don't think it was triangle.
No, I'm getting 120.86.
But it doesn't agree with C being, because then A and C would have to be smaller.
Well,
Smaller angles.
let's just, when it goes through here. Now, check it. Check it. How am I typing this in wrong? What did I do?
What's wrong? Do you have it on radian or degree?
100 squared plus 120 squared minus 2 times 100 times 120 cosine 20.
Do you have it on
I always put minus the 2 and 1.
Was it on radian?
120 in parentheses.
What I do?
You have it on radians.
No, if you put it on degree, you'll get
No,
close. Trust, yes.
42.98.
Yeah.
Yes, ma'am.
When did this change?
What's that?
Hold on. Hold. Oh, it's plus.
I'm solving the triangle. That one was the area. This one I'm solving the triangle. So from there, I'll start using my law of sines.
Wait, how do you know when to do that shindig? I don't.
You're using that one more often than not when you're starting with law of sines.
Oh,
Okay. So from here, we just go into sine of 20. As long as we are in degree mode.
no, it's over 42.88. 0.98, sorry.
That would have sucked if you counted that tomorrow. Wait, have you been here already?
I was here last week.
73, or 72.73. And then we just subtract it out. Let's see if it works. And what happened? What happened? It's not going to work, is it? Gentlemen, sit where you belong. Did you notice what happened?
Yes.
What?
It doesn't really work out
Why?
because it's
It doesn't work. You can get through the whole thing. Smallest angle, smallest side. Largest angle, not the largest side. It don't work.
I was right,
52
but with the wrong answers.
for the angle?
I got 52.
I'm 52 for C and 107. Yeah, I got the angle.
Did you switch it back when?
What?
No, 180, subtract out the 20, subtract out the 72,
No, I didn't get
no, I got 53.
I got 107 too.
Because I typed it in, I used. Okay, so this does work, I'm just an idiot.
Wait, what?
What was A?
107.2.
Oh, no, it's 107.
We got that on recording, right?
Yes, you do. You can make a loop of it, turn it into your phone ringer. Mr. Murphy's an idiot. Mr. Murphy's an idiot. Answer your phone. Mr. Murphy, yeah. When was the last time you actually got a phone call?
This morning.
Actually,
I get random
And let's go one more of these. Paige, you had a question.
Well, she didn't think it was my birthday.
What's that? Degree, we're using, everything we do right now is all degrees. You don't know what a radian is yet. We'll start talking about radians Thursday. Yes, sir. On that one you're starting out right off the law of cosines, you should be all right. Okay, I think you should wind up being okay on that one.
Wait, so law of cosines, we don't have to check.
It doesn't hurt. All I'm saying, I'm done talking over you. This is ridiculous. You always want to take a quick second to double check it. A lot of times, the first when you are with cosines, you do wind up. It happens where you're usually okay. It doesn't hurt to take a second to double check it. Okay. Lack of time and stuff right now, I'm leaving it up to you. A lot of this is up to you guys. All I'm doing here is trying to help you remember the setups of when we're using stuff. Make sure, again, you press the button on your calculator that says mode. Put it in degree. Make sure it is in there. Bless you. You guys are higher caliber people. I should not have to talk over you. What angle are you going to find first? Why?
because
Big.
it's the biggest.
Okay. 25 squared, 11 squared, 24 squared, 2, 11, 24, cosine A. Hit enter. Divide it out by your negative. Inverse your cosine. 82/16. That is an acute angle, correct? Okay. If it is an acute angle, it only takes a quick second if you want to try it with the 11. 11 sine 82, 16, regard relationship to the 25. If you type that in, does it work out?
It's less than.
It's less than, okay. What is the value of that?
It's 23.775668.
So it's 23.75? Okay. It's smaller than 25, but is it smaller than 24?
No.
No. So that means how many triangles is it?
One.
One. Does everybody see what we're doing here? We just pick one of them and check it real quick.
How do you know what ones to use? Like you did the 11.
All I did here is I'm using this as my bounce. As soon as I know a side and an angle opposite it, if that angle is acute, you can use either one.
So you can use 24.
Right. Okay, because then this will still, if this is smaller than this, you're fine. But if it's smaller than the other side, or excuse me, what do we use? The original one that you're checking with, then that's when you have the two triangles. Okay? That's when how that works out. You're using these two values, or using those two values. You're not parlaying it against the 24. You're working with just one of them and these two. And then you can, if you wanted to go the other one and try it with 24, it should work out as well to show that there's one triangle. Again, it's a law cosine problem. You found an acute angle. It takes 2 seconds just to look at it real quick. Because if there was a secondary triangle, then you could use, after you use your law of sines to find the next angle, you could just take that angle and subtract it for both from 180 and make your two triangles. Yeah?
So then if it was two triangles, you wouldn't change that first angle.
Correct. I wouldn't change the first angle. What I would do, if there was two triangles, I would use my law of sines to find angle C, because it's the next largest. Whatever that C value is, I'll have, let's say it's 63. It can be 63 or 180 minus 63. And then I would draw my second triangle and solve out for B with the two different values. It is completely plausible that it could occur like that. It just takes a second to check it. Sir?
Why don't we do 82 minus 1?
Because that's the first angle you found. Once you find the second angle, that's when because you have the side and an angle opposite, that's your pivot. You have to have that value for the first fraction. Find the next angle, that's when you mess with the minus 180. Okay? I hate getting mad at people. Come on. Do you want me to use law of sines the rest of the way? I'm trying to remember if there was another ambiguous case off the top of my head. Yes, sir.
Now, if you found an angle, can you continue to use law of cosine, or would it not work out?
You can. It just law of sines is so much faster. Once you get rolling on some of these things, the law of sines becomes so much quicker to work with. It just seems like it would just make a little bit more sense to use it. Okay. Let me show you another example of an ambiguous case, because I know this is where a lot of people are having a little bit of messiness. All right, right off the bat, you're given the fact that you have an acute angle and you know the side opposite it. You agree?
Yeah.
Since you're given that to start with, take a quick second and check it to see how many triangles you can wind up with. Take the 14 sine of 56 in relationship to the 13. Is it smaller?
Yes.
Yes. Is it still smaller than 14?
Yes.
Yes. So that means you have two triangles. So solve law of sines to find angle A like you would normally. Sine of 56 is to 13, as the sine of A is to 14. When I type that through, 14 sine 56, hit enter, divided by 13, hit enter. Second sine of my answer, I get 62.22, or 62.23, excuse me. Okay. Now, angle A could be that, or $116.77. What's occurring here is once you're identifying that you had an acute angle and the side opposite it, take the quick second to check and see if you're going to have the two triangles set up. If you do, use law of sines to figure out what the next angle is. Subtract that same value from 180. Now you just have two triangles to finish out with. You know a side opposite and its angle with the 56 and the 13. Find out what A is with it, if it's 62.23. Find out what little a is if it's 116.77. And then from there, it's just a matter of subtracting out from 180 to get two possible values for your angle C. And then use the law of sine again with that to find the other one. It's very systematic. Once you know that you have two, find one of them, subtract it from 180, and just draw two diagrams and solve it out. Okay? It's just doubling the workload, really.
What's the no triangle one?
No triangle is when it's the B sine of A is greater than B, I believe. Was that right?
Yeah.
Equal even one, it was 90. What's that?
Which B sine A is
Yeah.
And then
Yeah, greater than.
stop.
Yeah, if it's no triangle.
Yes, there's stop. Yeah. Yeah, because a lot of times you might be given something like this where you have angle A is 94, little a is 7, and B is 9. If you look at that right away, 94 would have to be the largest angle in the triangle, wouldn't it? Is A the largest side? No, so you know right away it's no triangle, just go on right away. It's really easy to visualize that, especially when you're given the obtuse. Okay? If the angle A was 74, you might have to play around with it. You might have to play around with it. Okay? That's all. Now, one of the, yes, sir.
When doing the ambiguous case, is the largest angle the one that is going to change? Or both, aside from the given angle, going to change?
No, the side from the given angle should be always the same. You're right that the largest angle is usually the one that changes because it could be obtuse or it could be acute. It's usually the way that it works. Okay, that's a good question. It's usually how it works out. I know that we're running short. What I wanted you guys to look at tonight is I just printed out one of the worksheets that had a mixture of sines and cosines and stuff like that on there, just to kind of give you a little bit of an idea of how something goes. I did not get a chance to verify if there's a double one in here. So I'm going to work on that in a little bit. I just don't want you to have to do all of this.
This quiz, you should be able to
The ones that I'd like you to look at are basically 8 through 16. Okay? I would look at 8 through 16. It's very straightforward. It's giving you a mixture of sines, cosines, or Pythagorean theorem, in case it's a 90-degree angle. Give you a heads up. And then there's 3 of them that have the area. They're using a mixture of both the sine area formula or the Heron's formula that we just talked about today with the S value. Okay. Look at those, and we should be all right. Tomorrow, like I said, it's law of sines, law of cosines quiz, a little bit of that right triangle trig stuff. It should not take very long. I think it's 6 questions. Okay. You should be just fine with it. Questions?